So in our lesson 9.2, this is just the first day of, I think we take 3 different days, we take notes in this lesson. Or have we? No, we have, we're just starting 9.2, aren't we? Okay. So first of all, let's define what an exponential function, some of the things that we can say about an exponential function. An exponential function is a function in which the independent variable appears in an exponent. So our x, or whatever variable is representing the independent variable, the control variable, the input variable, that's going to appear in an exponent. Here's its form. So every family of functions has its own parent function. The parent function for the exponential function is actually going to be f of x equals a times b to the x power. F of x, also known as y, is equal to a times b to the x power. And notice our independent variable x is up in an exponent. Matt?
I think we missed a line.
Did we?
Up by appears. Right there.
Oh, the variable x. Yes, thank you. The variable x appears in an exponent. And then now we wrote the parent function's name. F of x equals a times b to the x power. Well, a cannot equal 0 because if it does, I wrote it in the b, sorry. If it does equal 0, then that a value, it's a times any, or 0 times anything is 0. It's going to wipe it out. It won't be there any longer. So a cannot equal 0. B cannot equal 1. Because what happens when you keep taking 1 to a power?
It stays 1.
It stays 1. It doesn't grow. It doesn't decay. It doesn't do anything. It stays 1. So it can't be 1. And then we're going to talk about it when b is greater than 0, or in other words, b is a positive number. So exponential functions have these characteristics. What's that a standing in for? Well, the a is the value, when x is equal to 0. What's the value when x is equal to 0? Well, typically, in an exponential function, the x is representing time. So it's kind of like saying at starting time, what was the initial amount? What did it start at? What did that population start at? Or what did that bank account start at? When at time 0? Because what's anything to the 0 power, you guys?
0.
No,
1.
1. And what's 1 times a?
A.
A. So a is representing the value when x is equal to 0. And b is that thing we've been finding called a common ratio. When we have been finding a common ratio in our geometric sequences, we're really finding the b in our exponential function. And we've been calling the common ratio r. So now we got to get our brains wrapped around, r in this situation means the same thing as b. Or b means the same thing as r. So we got to kind of make that connection there. Okay, evaluating exponential functions, like anything, no matter what we're evaluating, we always have to follow something called order of operations. Yes, we have to follow order of operations. And how does that sequence go? What is the order of operations? What's first?
German dots.
German dots. Okay, what's the G then?
Grouping.
Grouping. Or in other words, anything that's in parentheses or some other type of grouping symbol. We take care of what's inside that first. Okay, what's next?
Exponents.
Exponents. Okay, we take care of any exponents that need to be done. What's next?
Multiplying.
Multiply from,
Or wait, no.
isn't it?
Regrouping. Sure.
Actually, we get to, I've never done the germ dots, so I'm not really sure.
It's a roar dots.
Yeah, I've always done PEMDAS. So
Yeah.
parentheses, E for exponent, M for multiply, D for divide, A for adding, and S for subtracting. So and once we get to the multiplying, dividing, adding, and subtracting, we work from left to right, okay? So order of operations, it sounds to me like we're gonna do the exponent before we're gonna multiply by 8. That's kind of what's gonna happen here. Okay, I want your books open to page 624. Find the check it out problem number 1. So again, your book is actually a resource also, so they have some example problems worked out in your book. And then we're going to practice some of the extra ones they give us below the example. So we're going to do the check it out problem that's below example 1. So the function f of x equals 8 times 75/100ths to the x power, models the width of a photograph in inches after it has been reduced by 25% x number of times. What is the width of the photograph after it has been reduced 3 times?
So x was 3.
So let's first of all write down that function that they gave us, that f of x equals. What was our a value in this one?
8.
8. And 0.75 is our what value? B value, and it's to the x power. Okay, so what did they say x is, what's x representing in this one? What's x representing in this problem? I think that's kind of an important thing to make sure that.
Inches.
How many times it's been reduced?
How many times it's been reduced. Good job, Garcia. How many times has that picture been reduced? Okay, so if it's not been reduced at all, 0 times, what is the width of that picture before it has been reduced? Look at, remember what we said? Anything to the 0 power is 1, and 1 times 8 is 8. So how wide was it before we even start shrinking it? 8. It's 8 inches wide. So it's 8 inches wide before we even do anything to it, and now it's saying, what is the width of the photograph after it has been reduced 3 times? So what are we going to do?
You're gonna put your x is gonna be a 3.
Your x is going to be a 3. We're going to substitute 3 in for x. It's going to get reduced 3 times. Order of operations. Order of operations says do what first? Do we take 8 times 75/100ths?
No.
Or 75/100ths to the 3rd power? 75/100ths to the 3rd power. And we're going to actually write this step out. We're going to show it.
Oh my goodness.
So 8, and what does that become?
0.421875.
Okay. So when we take 75/100ths to the 3rd power, we get that decimal. And now we multiply that by 8 to know what is our f of 3, or in other words, when you put 3 in for x, what do you get?
3.375.
3.375. And we know that those are measured in what?
Inches.
Inches. We just found the width of the picture.
Isn't this exactly what we were just doing yesterday?
Kind of is, isn't it? Without using an equation.
Which got like a lot better. I
So-
don't think so.
F of 3, it's been shrunk 3 times, reduced 3 times. We end up with 3.375 inches wide. Was I talking about the picture, not the line? Am I right?
Yeah, I think so.
Okay, so does anybody happen to know what decimal that 3.375, what fraction I mean that 0.375 is representing? 3/8 is what it actually is. It would be 3 3/8 inches. Now, notice, what's our B value? Is it greater than 1? Or is it between 0 and 1?
It's greater than.
Our B value.
Oh, just kidding. It's between.
our B value was between 0 and 1. And what do we say should happen when our R value is between 0 and 1? It should get larger or smaller? Yeah, whatever we're getting should be smaller, and so I'm feeling pretty good about our answer. So any questions on that one? That's the work you need to show to support your answer, to justify your keystrokes in your calculator, okay? Okay, here's another one that we have. This one's just more practice, number 2. The function f of x equals 500 times 1.035 to the x power models the amount of money in a certificate of deposit, a CD. That's not a, I'm not talking about a CD we put in a player. We might hear music out of. A CD, a certificate of deposit, after X years. So it's a way of saving money. How much money will there be in 6 years? Well, notice it says X is representing
Years.
years. So where are we going to put that 6 in?
For X.
And for X. So f of X equals 500 times our B value, also known as our R value, raised to the 6th power. Jossie?
Okay, so on your final answer, I know we're not there yet, but you can't have, it's gonna clearly be a decimal.
It is. And what are we going to round it to be when we talk about
The
100?
nearest 100.
To the nearest 100. In the end, we'll round it to the nearest 100.
Okay.
When we're talking about just kidding.
Is that what you were going to, you're
Yeah, I
kind
thought
of
we
what?
were talking about years, and I was gonna say you can't have one.
No, we filled in for the year. So we're getting how much money will be in the account. So we're looking for the amount.
Do you want us to round this part right here?
So no, we're not going to round here either. We're
Okay.
going to write what our calculators say. Okay.
1.229225526.
I got 1.229255326.
Whoa,
Exactly what I got.
Oh, I thought you said 2 2.
I got
I did.
1.194052297.
You should have.
I wonder if you forgot this 0 in here when you did this maybe. 1.035 raised to the 6th power.
1.22925.
Now you're on the same page.
There you go.
Okay. And then now we're going to multiply by 500, and I won't make you write down that whole number if you don't want now, where you can round it to the nearest. Well, you know what, maybe we should write it down so we know what, and we all get the same thing anyway, right now in our notes. So 614.627.
6276632.
Okay. So we just found out that f of 6, and remember, f of x is representing the total amount of money. So f of 6 is
$614.63.
okay. So,
That's all you get after 6 years?
well, you know
I
what?
thought it
Does
was
anybody think they know what the rate of interest was on this one?
Not very high.
Yeah, not very much.
Okay. Do you think you have any idea what it might be?
Have a better chance on the stock
Like 3
market.
cents.
Not a percent. They do interest rate in percent. I'm going to tell you right here. Here's your clue right there. Remember, percents are changed to decimals. Anybody think
75%.
75%? No. 35%?
33.
If it was 35%, wouldn't that be?
If it was 35%, we'd all be rich.
Yeah, I want a savings account that pays 35%, or a CD that pays 35%.
3%.
It's 3.5%. Yeah, this is certificate of deposit is actually paying 3.5%.
Well, it's better than
I had that much in my account 2 days ago.
So it's kind of like we move the decimal point over 2, and it's half. It's
Well, to be honest with you, 3.5%, that's better than my bonds I have.
Yeah, right now that's not bad in this, at this time. Okay, let's go to the next one.
I like this stuff. I like it better than
The function f of x equals 200,000 times 0.98 raised to the x power, where x is the time in years. That's kind of important. You always want to do it. You always want to point, say to yourself, oh, x is years. Models the population of a city. Well, then the population is going to be what? What variable is that really going to be? It's really our f of x, also known as our y. I'm not going to say equals y, I'm going to say or y. F of x or y. So the population, we can find the population by taking 200,000 times 0.98 raised to the number of years. What will the population be in 7 years? Hey, can anybody right now, before you even put your pencils down, put your pencils down. Tell me, put your pencils down. No, there's no calculator needed here. There's no pencil needed. There's no calculator. I promise you, you can answer this without it. What was the population at the start?
200,000.
200,000, yeah. See that 200,000 there? Remember I said A will always represent the amount at the beginning. Yeah, at the beginning. So the population is 200,000, while our R value is greater than 1 or between 0 and 1?
Between 0 and 1.
Between 0 and 1. So should the population go up or should it go down?
Down.
It better go down, right? We better get a number less than 200,000 here or we did something wrong. Okay, so f of x equals 200,000 times 0.98 raised to what power?
7.
7th power, 7 years.
Oh boy.
And I bet this is a nice long decimal too, isn't it?
Yes,
Very
0.868125533.
Holy cow.
Maybe
I think I'll
later.
look at my sheet.
I mean, when I shall write one.
Okay.
Girls. Okay. Woo!
I don't
Yeah,
know,
right,
just-
right?
Yeah. Wait, is there 2 there?
Okay. So now we do the multiplication type. So you don't want to wipe that off your calculator, right? Now you want to take it times 200,000, and what do we get?
173,000.
173,625 point what? 1066.
I got 7.
You
Yeah,
get
I got
6.
that, and that, yeah.
Okay, this is this little dot that's in here right now. That's not supposed to be there. Well, wait a minute. Eraser. There we go. Okay.
7.
And now we would say approximately equal to, because we can't have, we don't talk about parts of people, rounded to the nearest person. How many people?
So,
173,625.
Yeah. That 1,066 10,000s isn't enough to round up to the next person. So we would say f of 7 is approximately 173,625 people, persons, whatever. You don't say population. Always what makes up this population? Because there can be population of dogs.
Robots.
There can be population of robots. There can be population of clowns.
No, that's scary.
I hate those.
I can't stand clowns.
Okay, whoa.
You guys stop talking.
Okay, stop. I know. Okay, questions in that one? Did we get a result that we can accept? Why can we accept this answer?
Because it got lower.
Because it got lower, and we said it should get lower, right? Okay. Okay, now let's go to number 4. If a golf ball is dropped from a height of 30 feet, oh, notice there's a 30 in the equation. What is that 30 representing again?
Height.
Or the
Where the height starts at, it's 30 feet off the ground, that golf ball is being dropped from a height of 30 feet, so a 3rd-story window or wherever, okay? And it gives, then we have the function 30 times 2/3 to the x power. It gives the height in feet of each bounce. So height in feet is our x or our y value?
X. No,
The
just
Y.
9.
This is really our y value, also known as f of x, right? And x is the bounce number. It's always important to make sure you understand what are your variables, especially your x. What's it representing? Take the time to read that. Okay, well, our R value, is it, what should our result be? Greater than 30 or less than 30?
Greater than.
Less than.
Reasoning?
Less than.
Because it's between 1 or 0 and 1.
Our R value is between 0 and 1, so it has to go down So it's gonna be less than 30, our answer when we're done. So what will be the height after the fourth bounce? Round your answer to the nearest tenth, it says there. So f of x equals 30, and we're not gonna do this with our fraction key in our calculator. I'm gonna show you how we're gonna do this.
Oh, that's
I'm gonna
silly.
show you how we're gonna do this without that. Okay? So, that we all get the same rounded answer maybe when we're done. Okay. 30, 2/3 to the fourth power really means 2 to the fourth power over 3 to the fourth power. So let's write that out so we understand what is it we remember when you're taking a fraction to a power. What if they left the answer in an answer bank as an exact answer and they did not want a fraction? So we have 30 times, what's our numerator become? What's 2 to the fourth power? 16. What's 3 to the fourth power?
81.
81, or 3 times. Okay. So 30 times 16, 81st. Oh, guess what? We can make this into a fraction by putting it over 1. What goes into 30 that also goes into 81? 3.
3.
This is a power of 3, and 3 goes into 30, doesn't it? So let's do some simplifying here. 3 goes into 30 how many times?
10.
10 times. How many times does 3 go into 81?
12.
27.
27.
27.
Okay, now we're going to keep going. 10 times 16,
160.
160.
Over 27.
Over 27, 1 times 27. And
Yeah,
now we
same
will
thing.
divide that out, and we'll say f of, was it 4,
Stretch.
is approximately equal to, rounded to the nearest tenth of a foot.
5.93.
5.
No, she said rounded, silly.
6. Well, she usually makes us write it in our notes
No,
first.
but here, because we were working with a fraction, I let you, we're doing.
5.9.
So now we're dividing this out, and we're saying it's approximately 5.9, nearest 10. 10. 10.
26?
Okay, here's what the calculator gives, right?
They're out.
Okay, let me write down what the calculator gives.
Yes, and the 5 tells the 2 to be a 3.
Okay, tenths. Where's the tenths
Oh.
place?
The first one.
Right
Oh,
here.
yeah.
This is the one we look at. So is that big enough to make
So
that?
stays a 2.
No.
Stays a 2.
Stays 5.9.
So I mean, that doesn't stay a 2. This stays a 9. Yeah, so it's 5.9. And what was the label? Feet. What are these measured in? Feet. Its bounces are measured in feet. So we're saying after the fourth bounce, that fourth bounce is about 6 feet off the ground, almost 5.9 feet. Okay, drop from about a third story window. The fourth bounce would come up this high.